Good morning, ladies and gentlemen. My name is Helen Shenton. I'm the librarian and college archivist at Trinity College, Dublin. And it gives me enormous pleasure to chair and to introduce our final keynote speaker, Alan Akbik. He's from the research group of Zalando. And this keynote takes us deep into the world of the fourth industrial revolution. Because Alan's going to talk about the big issues of machine learning, of deep learning, of artificial intelligence, and so on. And I missed most of the reception yesterday because we had a run-through. I understood most of it. It's absolutely riveting in terms of where we're going. Just to give you a vignette of these different worlds coming together. So when we were talking, at one time, Alan said, oh, this is a really long-term issue. And so I said, well, what's long-term for you? And it was a year. And speaking as someone from a conservation background, 200 years is an eye blink. So I was also intrigued to learn that of the 16,000 employees of Zalando, 8,000 are in Berlin, and it's the biggest employer in Berlin. And the research group, there's about 10 of you, I believe. But anyway, so Alan's going to talk to us for about half an hour, and then there'll be time for a conversation. So, Alan, please.
Okay, thank you very much. So for us, 1 year is a really long time because we are looking at technology and technology developments in the areas of text and data mining and artificial intelligence. And here in 1 year, actually a lot of things can happen. And so the title of this talk is Teaching Machines to Read and Understand Text Data. And as Helen has mentioned, we are a industrial research lab. So when we teach machines to read and understand text data, we're not doing this because we are teachers or because we're philosophers. It's because we want these machines to actually do something for us, right? And since you guys are people who have a lot of text data, I would like to discuss with you a few technologies that have been around, technologies that are emerging right now that potentially could be useful for you guys and your guys' use cases. All right. This talk is structured into two parts. In the first part, I'm going to talk about standard text and data mining. So this is text analytics where you have text data and you want to extract information from this text data because you have some sort of an information need that you want to satisfy, right? So this has been around for a while. In the second part, I'm going to look more into artificial intelligence and natural language understanding. So this is things that we are discussing right now in the research community. There's amazing progress being made in artificial intelligence. Actually, this is the year, and next year is the year where we're making huge breakthroughs in artificial intelligence. And we're actually teaching machines to understand how human language works so that we can get to the point that these machines can more and more speak to us, in a sense, right? And so here again, we are using text data, but we're using this text data to teach the machine how human language actually works, right? So we will start with the first part. So text data and fashion. So who actually here knows about Zalando? So I've talked to some people, so some people know it, okay? And some people have never heard of it. So I'm going to give a very quick introduction, okay? So just by the numbers, it's a pretty big company, as Helen has mentioned. So it was founded 10 years ago by 3 people in Berlin who were selling shoes online. And this company is an e-commerce company, has grown to be extremely large. 10 years later, it's 16,000 employees. It is the fastest growing company in Europe. It's also basically Europe's only really big tech company that has appeared in the last 10 years. Has active in many different countries in Europe and a lot of different customers and a lot of products that are being sold online. So it's kind of like a mini Amazon, right? Because we have so many customers and so much products, there has been so much data that's being generated. You can imagine the logistics, the customer interactions, all this data has been generated. And because of this, they decided 2 years ago to start a research lab, an industrial research lab, that looks into very new artificial intelligence technologies to actually do something with this data, right? And so I'm a text guy, I think like you guys. So I joined the company 1.5 years ago. And when I came back to Germany to join Zalando, I was actually not so sure how much text data is there actually in fashion, right? And it turns out, in fact, there's a lot of text data. So for instance, there is a whole universe of fashion magazines, fashion websites, fashion blogs, right? So people, they discuss things like, oh, I bought this dress and it goes super well with this dress, and in Berlin everybody's talking about that. So they talk about the trends, they talk about fashion, they're super enthusiastic about this stuff, right? So there's like this whole publishing stuff. At the same time, there's also microblogs, so this is like Instagram, where people, again, super enthusiastic about fashion, they say, okay, I bought these new sneakers. They take a picture and take a picture of themselves, and I'm walking down the streets of Berlin. This is me and my new sneakers. So people, some people are extremely enthusiastic about this stuff, so they propagate it into the world. And this is also content, right? So the websites are content, and the magazines are content, but this, like microblogs, for us are also content that is interesting to us, right? At the same time, because we are a web store, people can actually interact with this web store in many different ways. So for instance, as you know, when sometimes you buy a product online, you can leave a review. So you can say, oh yeah, I bought this review and I give it 5 stars, and you can write a bunch of stuff. So here's some examples. These are very short reviews, so some people write big reviews. They write, I bought these shoes and I wore them to the wedding and everybody said they were so nice, blah, 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 right? So people are super enthusiastic again, yeah. And this is just one example. So there's also other types of feedback. So in the website, we always ask, how did you like your shopping experience? So people can answer that and they write text. And so essentially what we have, there's also search queries, but there's many different types of ways that the people interact with the platform. And this is all human language because humans speak in language. So we communicate in this format. And so if you take all these sources of information together, you find that there's actually a whole universe of fashion-related text data out there. And what is also interesting for us, since we sell fashion to customers, we are actually interested in what people are saying in all these things, right? So we are interested in what are people talking about in Paris? What are people talking about in Berlin? Or if it's Zalando-specific data, what do people like about a company? What do they not like about a company? What do they think should be improved, right? So in a sense, we have a situation where there's all these different data sources, it's all in text, but we are sure that there's information in there that is interesting to us, that we need. So the question for us then is, how do we get this information out of all these data sources and put them in some format that we can actually use? And maybe you guys have similar problems as well, right? To make the matter more difficult, this data is not only in English, right? So these examples are in English because this talk is in English, but in fact, we operate across Europe, and most of our data is actually not in English, it's in all the European languages, right? So with German and French and Dutch and Polish and all the different languages are represented in our customer base. So it's not only that this information is distributed across these different sources, it's also in all sorts of different languages. And again, the question is, how do we get the information out so that we can actually do something with it, right? And so for this, we're developing and using classic text and data mining technologies. And I want to take you through 2 technologies that are key to actually doing this. And the first technology is called document classification. So this is an old task. It's been around for 20 years. But essentially what you're trying to do is you build a machine that can read a document and put it into a folder or into like a class that you have defined yourself. So essentially in a newspaper scenario, for example, you might tell the machine newspaper articles, put all the articles that are about politics into one pile and put all the ones that are about sports into the other pile, right? So this is essentially a machine that categorizes your data for you. Of course, we don't have newspapers and we care about fashion, so our documents, in this case, are, for example, user feedbacks that the users have left on the website, right? So maybe a user might have said something like, oh, quick delivery, thank you very much. And then we define a class, and this class could be something like delivery fast, because we're interested, are people happy or unhappy with the speed of the delivery of the item that was delivered, and delivery slow. So let's say for a simple use case, we just define 2 classes. And now we're training a machine to go through all the user feedback and put all the ones when they said the delivery was fast, put them into one pile, and all the ones where they said it was slow, put them into the other pile, right? And so what the machine does with these 2 examples here, it'll put the document 1 into the first pile and document 2 into the second pile. And this is actually quite nice because we can define a lot of different classes, so these are only 2, but in many use cases we might have hundreds of different classes, very fine-grained feedbacks of what people liked and what they don't like. And once we have a machine that can actually do this, we can run this over the entire data set, over all the data. And while it is expensive, fairly expensive to build a machine that can do this, once you have it, you can run it over all your data. And the nice thing about this automatic class categorization is that you don't have to worry so much about whether your category system is actually perfect. So maybe 1 month down the line we decide, oh no, we need another category. So if this was a manual categorization effort, this would be a nightmare. We would have to go back and relabel everything. But if it's a machine, it can just do it, right? So this actually, it's very convenient for us. So this is one technology. So we take the feedbacks. One thing that I should point out, this image is actually not a bit wrong in that in this machine scenario, one document can belong to multiple categories. So here, the file folder is kind of like a wrong image here, right? So this is the first technology. A second technology that we do is a bit more fine-grained. So here, this is called sequence labeling. So you may remember in school when you had to like read essays and the teacher would ask you to like highlight certain things in certain colors. I don't know if you all had, I had to do it in school at least. Yeah. So essentially we are training machines to do the same thing. So we're training the machine to go into the document and take different colors and highlight different types of information in different colors, essentially, right? So if we go back into this blog post and just a bunch of blah, so what the machine will do then, we've trained it, for example, it will highlight all the locations that are mentioned in this document, blue, yeah? So it will be Berlin is mentioned here, and Paris is mentioned here, and Winnipeg is mentioned in this document. And the machine does this automatically, right? Just imagine a human having to do this, yeah? Then another class that we have, so this is would be like products if people talk about ankle boots and, I don't know, certain types of fashion items. And also different colors for different things. And we have, again, a system that can detect many, many different types of these things and highlight them automatically in the text. Again, so if you have a human can't really do this. So going through so much text and marking this up, people would go insane. But the machine can do it once you've trained it, which, again, is costly. But once you have it, you can run it over all your data. Yeah? And so this is actually also really useful because in the first technology, the document classification, what we basically have is a fixed set of classes, and we put the entire document into this class. Here we're actually going into the document, and we're highlighting certain bits of information. So for example, statistics that we can generate out of this are what kind of people are being mentioned in these fashion articles. Maybe certain people are influencers that are really famous, right? Or what kind of cities are often mentioned together with trends or which brands, right? So we essentially can go through all the documents and collect statistics that will tell us a lot about these trends and the customer behavior, right? And so essentially, if we take these two technologies together, what it can do is take all this text, so these are some German reviews, and then spit out these charts, essentially, pie charts and graphs. And this is possible because we are classifying and because we are getting these structured information out of the text data. Another thing that's cool about it is because it is, once you have the system very cheap, you can basically continuously run it. So our data is incoming every day, and it's a lot of data that is incoming every day, more than a human can read, again. For example, all the feedbacks that we gather from the customers. And now we can have the system, we can run it just non-stop. And we can see over time how do the trends develop. Maybe somehow in this region, people are suddenly saying, oh, we would really like to have this brand. Or in this region, people are saying, oh, why is delivery suddenly so slow? So we can actually react much more quickly to changes that happen because we do this type of monitoring. And so, yeah, so to maybe like sum up this traditional text analytics, it's not summary yet, but one thing that is important is that throughout all this text data, customers tell us what they like and what they don't like. And thanks to text analytics, we can actually listen to these customers a lot better, using the core tasks of sequence labeling and classification. Now, one thing that I've mentioned is that the upfront costs of building such a system are actually fairly high. So maybe you're asking yourself, why doesn't just everybody do it, right, with everything? So there are significant costs in actually building such a system. And I can tell you why. So these tasks in machine learning are typically modeled as something called supervised learning problems. So in supervised learning, the machine is doing the learning and the human is doing the supervision. Okay? So the human is essentially teaching the machine to do this by showing the machine examples. And you have to show it a lot of examples of the thing that you want the machine to do. And generally, the wisdom in machine learning is that the machine can basically learn to do basically anything you want, provided you show it enough examples. So if it's a really hard task, you need to show it like so many examples. And if it's an easy task, maybe you don't have to show it so many examples. Okay? So going back to these examples, so the examples that we had, let's say we have this class, we had it before. We want to know how many times have people mentioned that the delivery was fast. So we want to train a system to do this. What we need to do is find instances where people have already said this and tell the machine, this, for example, is how people would say the delivery was fast, right? So but you would show it like, this is called a positive example because it's a positive example with regards to this class, right? But you can't only show it positive examples, otherwise the machine doesn't know what to distinguish from. So you also have to show it a negative example that does not mention this class. So you're going to show it some other thing, and somebody writes maybe I love Adidas, you're going to show this as a negative example. The thing, however, is one positive example and one negative example is not enough for the machine to learn to actually make this distinction. So you're going to have to show it typically thousands of positive examples and thousands of negative examples. And that means that a human has to sit down, go through all the data, and find examples to show the machine, right? And so you may think, okay, 1,000 examples, that's a lot, or 5,000 examples, that seems like a lot, but okay, I'll sit down, I'll do it for a week. Got it. The problem is that this is only one class. And in many cases, you won't just have one class. You might have, we have use cases where we have hundreds of classes. So you need to find these examples for hundreds of different classes. And also, to make it even worse, you need to find examples, 1,000 examples for each language. Because the languages are different. If you train the machine just throwing it English examples, and then comes a German who writes something, the machine won't know what to do with it, right? So you need a lot of training examples, and this is typically a high upfront cost of training the machine to do this task, right? And this is kind of weird if you think about it, because a human can actually do this very quickly, right? So if I asked anyone of you to make the distinction, did the person say the delivery was fast, you can immediately do it. Maybe I have to show like one example or two examples, and you can immediately do it. But why? Why does the machine need thousands of examples for this? And I guess one answer for this is that the human has a lot of things the machine doesn't. The human has world knowledge, it has understanding of language, it has experience from a whole lifetime of living, right? So when we teach the machine starts at zero. When we teach a human, the human starts from a pretty high base, right? And so for us in artificial intelligence, the question now is, so these were classical methods, can we change this? Can we somehow simulate artificial intelligence in the machine? Can we simulate language understanding in the machine to such a degree that the machine can learn to do things quicker and better, right? And this brings us to the second part. So now we're looking at the research that is right now bleeding edge. People are, like I was saying in the beginning, so people are making amazing progress, and a lot of this is due to buzzwords you probably heard about. You've heard of deep learning, or at least the buzzword you've probably heard. You've heard of artificial neural networks. And these things are very much revolutionizing the way we deal with data, and especially also for visual data also, but also for text data. So visual data came first, that was maybe 2 years ago, but now text data is in the focus, and we are using these neural networks to build things like much better text analytics approaches. And you may have noticed, so if you use, for example, translation systems, you may have noticed that the quality of these automatic translation systems, Google Translate, for instance, has jumped just magnificent. So 2 years ago, comparing that to today, is night and day, because 2 years ago they were using different approaches, more standard approaches. Now they're using these neural approaches, and suddenly everything works so much better, right? So it's a huge revolution that is going underway right now. So the question is, how can we train the machine to understand human language, okay? And so again, we're using text data, but now we're not using text data to analyze it, we're using text data to teach. And in this case, the general high-level intuition, so the high-level intuition is that if we have huge amounts of text data, and you have huge amounts of text data, we can crawl huge amounts of text data from the web, and we push it through a neural network, which is basically like an artificial brain in a sense, right? So we make this thing read incredible amounts of text data with huge computational power, with a huge neural network structure, and we make this thing read it for months or weeks at least, then at some point it will start organizing this data in such a way that makes sense to the neural network. So the neural network will learn things about the structure of language. And maybe to illustrate this with an example, so of course we don't just give it text and then it does something by itself. So we actually ask it to do something. So what we, forget this, so what we do is we put the text in there word for word. So we have a corpus of text, and we give the neural network one word at a time, and at each word we ask the neural network the same question. What do you think is the next word? Right? So here, let's say the neural network has already seen, because it was hungry, the cat. And we ask the neural network, what do you think is the next word? And the neural network will somehow try to guess based on its understanding of language, and it will probably in the beginning, definitely it'll guess wrong. It'll just choose some random word, and then we tell it, no, actually the next word in this case is 8. Okay, because that's how it was in the text. And then we give it the word again, and then we say, we repeat. So okay, so now the sentence, because it was hungry, the cat ate the. And we ask the same question again, what do you think is the next word? And then the neural network will start guessing, and it'll have its language understanding, and it'll probably guess wrong again, and then we say, no, it's actually the. Okay? And then it continues and on and on and on. So, but we don't just do this with 3 words, we do this with just amazing amounts of data. So 1 billion words, easy, right? And so, if you think about it, in order for this neural network to be able to guess the next word, there are certain things that this network has to learn. It has to understand the sentence up to this point to a sufficient degree to be able to guess the next word, right? So one thing, so you train it, in the beginning it'll be gibberish for a while, just complete random guesses. But at some point it starts learning some things, and it starts saying, for example, frequency of words. It'll say, okay, it'll notice some words are more common, because you always say the. Like every 3rd word you give me is the, right? So it'll start learning that, okay, some words are more common than others. But it'll start learning even more stuff. So for instance, it'll start learning that, okay, we have Kate at the. After the, it's very often either an adjective or a noun, right? In order to understand that something is an adjective, it'll actually learn that certain words are nouns and certain words are adjectives, right? If you look in the first example, because it was hungry, the cat ate. This is tense agreement. It was hungry, it ate. So it's past tense, both verbs, right? So at some point, the neural network, in order to be able to guess this, it has to understand that there is at least the concept of tense. It also is the cat ate, but it's not the cat eat, right? That would be number agreement. So the cat is 3rd person, singular, and so the verb also has to be 3rd person singular. So this is tense agreement, this is number agreement. And so, as we run this forever, and I mean we run this for a long time, right? So I literally throw this machine on, I go 6 weeks on holidays, and it's a huge machine, right? Very expensive. And then I come back and it's still learning, right? Because it's a really hard problem. It has to go through so much data, and it has to learn like all these things by itself. But almost magically, it actually does. And so things that we learn, I've mentioned this, we learn shallow syntax, like parts of speech, that's noun, verbs, adjectives, but also agreement, morphological features like tense and number. It'll start learning sentence-level syntax like constituents, subordinate clauses, quotations. It'll learn punctuation. It'll learn a lot of different things, and it even partly will learn shallow semantics, such as sentiment, topic, and even semantic roles. So to a certain degree, it will also learn semantics. And so the question now is, okay, so we train this huge neural network, and it's not human readable, right? It's like a net of neurons that are all connected with each other, kind of like a human brain. And now the question is, after I train it for 6 weeks, how do I know if it's actually good, right? And so one simple way that we do is we ask the neural network to produce content for us. We say, neural network, write a text for me. And it actually can write a text for you, because writing a text is basically just guessing the next word, but we're not correcting it, right? So it guesses the next word, and we say, yeah, sure. And then it guesses and guesses and guesses and guesses, and then it basically has written a text for us. So the neural network can, in a sense, create content. And here are some examples after 1 week of training. It's actually nice to look at it if it's not fully trained, because this way you can see what things are easy to learn and what things are hard to learn. And what you will notice from these examples is that, for instance, syntax, creating syntactically and morphologically correct sentences is something that the neural network picks up on much quicker than actual semantics. Semantics is much harder, right? So if you look at the second sentence here, according to ADA attorney Stacey Bailey, prosecutors have requested that all of the country bend to him rather than require him to accept the legal fees. Now that's a pretty involved sentence. With a subordinate clause, it has requested that rather than. So there's a lot of structure in the sentence. It doesn't semantically make so much sense, but at least it's, that could be some confused person who could have written that. Some confused person who knows syntax, right? If we look at the upper one, the first one is actually more funny. And you notice really that the semantics is something that is a lot harder for the neural network. So it says the visible food contained weirdness. So according to, we got the quotations here, that's pretty good, because it means somebody has said something and it knows that something else has to be put in quotations, right? But the visible food contained weirdness or unknown firestorms. Makes no sense, really. So this does get better. So this is after 1 week. So if we train it for 6 weeks, it will get a lot better at this. But it generally still cannot, it'll be able to generate sentences very often that are basically perfect and make total sense. But if you ask it to write like a text, I don't think you can fool any human. So there's going to be breakdowns in semantics somewhere where the whole text suddenly doesn't make any sense anymore. So semantics is only approximated here. But syntax is actually understood very well. So now, what does that actually mean? So now we have this neural network, and it has some sort of language understanding. Maybe the question now is, why did we actually do this? So why do we want to do this? And as I mentioned earlier, a big point of this is that we want the machine to do things for us. And instead of the classic approaches where we start from nothing and show it 1,000 examples, we want this machine to start from something that approximates human understanding of language or the world, right? So forget this slide. So this is, you can also look into the neural network and visualize what individual neurons do in the network, but this is maybe not so important. The important thing is that now that we have trained this language model, we can plug it into our text analytics. And it looks like this. So this is maybe a bit technical, but the important point is that at the bottom is the yellow model, is the language model that we have learned, that understands human language. And on top is our text analytics module. And when we train this module, they're connected now. The module that we train can draw upon the knowledge that's contained in the language understanding module. Okay? And so this is an approach that we have developed at Zalando Research. And it turns out that this approach is actually super powerful. So we showed that across a whole bunch of classic text analytics tasks, we outperform all the state-of-the-art approaches that are currently around, because this approach is just really powerful. So we evaluated it for approaches, semantic approaches and syntactic approaches for English and German, and we show that basically across the board this approach is a winner, and we can train really powerful language understanding systems. So maybe some takeaways. We can use massive amounts of text data to train neural networks that mimic the understanding of human language, especially syntax, but also a little bit semantics. We can then leverage these models to create much better text analytics tools. So on the one hand, because we are basing them on this knowledge, the text analytics is actually much better. At the same time, because it starts from something, we actually don't need to show it so much data. So I don't have a slide on this, but we have another project where we did document classification with this. And for instance, we can show that for tasks where we before needed 2,000 examples, now we only need 200 examples. So that's one order of magnitude less, and in terms of cost reduction, that's very significant. But at the same time, you may notice that 200 examples is not 2. The human would require 2, okay? So we still, or maybe 10, maybe the human requires 10 examples. So 200 examples is not 10, so there is still some way to go to getting this language understanding to be even better so that the machine can do these tasks even better. We discussed 2 types of text analytics, the document classification and the sequence labeling. I'm actually very interested to learn if these types of tasks might be interesting for the data sets that you guys have. And I also want to point out, since I think a lot of you have a lot of data, and you might want to do text analytics, we are actually sharing the wealth. So the text analytics tool that we've developed is partially open source. So if you guys are engineers, or if you guys have engineers, you can point them to this project. It's called Flare. And they could probably download it and run it over your data. So this is something that that could be interesting for you guys. So I think I may have been a bit quick. So yeah, but that's it. Thank you very much.
Alan, thank you so much. That was inspiring. So before I hand it over to the audience, I had a question yesterday that I'll see if you had thought about it overnight. So when I was at Harvard, one of the things I was responsible for was the Harvard University Library, Harvard University Archives, forgive me. And that had 850 million leaves of inaccessible content. So in about 2010, 2011, we got a room full of computer scientists and a room full of archivists, and we had a think-in in terms of how could we accelerate access to that material. And this was at the Radcliffe College, and then we reconvened a year later. That is still largely inaccessible. Now, would this, given that this is big content that we could turn into big data, is there potential to make that accessible?
Yeah, so I could see that. So essentially, so you were mentioning it was 2011, so that is a long time ago. So we talked about how 1 year is a long time. That was actually before deep learning, or mostly before deep learning and neural networks. So since the revolution is underway, I could imagine that if you gather a group of computer scientists into a room today, the answer might be different. So what I could see, so this approach could not directly be applied to it, but maybe a modification of it could. So where you, just like how we train the neural network, we feed all this data of your library into, or the archive, into some sort of a module that tries to understand what is being said in these things. And I could imagine some approach where this would allow people to access this data more as in a way, okay, I'm looking for, I don't know, for certain types of information, and perhaps a neural network. I think this is still maybe 1 or 2 years in the future. But at some point, I could imagine that this information is stored in such a way that the network actually remembers where it got it from, and then maybe could point the human in the right direction. So I don't think that's too far away, at least.
Excellent. Yeah. So thank you. I'll hand it over to the floor, please.
Oh.
Hello, this is Christina Vermeer from National Library of Finland. So I don't have a question, but I just want to tell the audience how we met earlier this year and why we met. So as you know, LIBER has been lobbying for the copyright reform and copyright exception, especially related to TDM. And we have, during the years, we have met 4 commissioners, and the last one, the Bulgarian, Maria Gabriel, we met somewhere in March, during spring. And the concept was that we had their legal experts and certain organizations, so LIBER was responsible of the event, but then we had, for example, Science Europe, but then we had Alan there, and then people from startups. And I believe that it was the most powerful part. We needed to have the expertise about the content, so why we needed to have this TDM exception. So we needed to have the legal expertise, but then we had to showcase so what it means in research. So we had some researchers, what it means, for example, in business, in startups. And sort of this opened the eyes of the commissioner and also the decision makers. So it was very, very good event, and what I'd like to say that collaboration between different stakeholders is so important. So beforehand I couldn't have believed sort of what that event brought, but it was so important. And also here So Zalando and library is sort of not a very sort of easy connection, but we can see we are using this kind of methods at libraries, and we are using it more and more. So it's so important. Thank you. It was excellent.
Are there other questions, please? Could you say your name and affiliation, please?
I'm Demi Verbeke from Leuven. So you can now train the machines to write text, basically. Can you then also say, like, now I want 7 blog posts in 7 different languages about a certain type of shoe? I want 10 reviews in 10 different languages about, and is it then the idea of Zalando that you will sell to suppliers that possibility? That, like, if you can trade through us, and we will also give you 10 good reviews and 7 good blog posts? Or is that not the business plan?
Nobody has told me, so I don't think that's a business plan right now. However, you are correct in that. So when I said the machine can write text, the example that I used was that the machine would just write random text. But it is true that you can condition the machine. In a certain sense, you can supply a topic to the machine, and then you could say, write a topic like in a certain way. So there's research going on this, that you initialize the first state of this neural network in such a way. I don't think at this point you could direct it to write about a specific shoe, but you could probably direct it to write about like a review, or I don't know, be positive or be negative. So more and more research is being done in the area that you want to basically tell the machine, write me an article about this. And this is actually not limited only to text data. So we are doing research. This is another division in Zalando Research about generating images, right? So you could tell the machine, you could give it a textual description, a shirt with stripes and, I don't know, some description, and it will then generate an image for you based on the description that you have supplied, right? So there's research going on in that area as well. So artificial intelligence research is not only text, obviously, it's not only human language, it's also computer vision, for instance, and also intelligent control. Basically, all the things that you previously thought only the human can do, like speak a language or recognize a stop sign on the street, and more artificial intelligence can do some of these things at least, right?
Thank you. I'm going to invite any questions from our colleagues in Amphitheatre B. Do you have any questions in the next door amphitheatre for Alan? I'm not hearing any. So we'll go on here. Up at the back, please. Right at the back. Yep.
Hi, my name is Marton Villa. I'm from Institute of Science and Technology in Austria. I'm wondering, libraries have data what is normed and it's correct, let's say, somehow. Your source is social media, for instance, what is not really semantically correct or grammatically correct. How do you deal with this problem, or is it a problem?
It may be a problem, but it doesn't have to be. So the thing is, so you want to train your model to be good in the domain that you want to apply it on. So let's say your use case is actually social media. Then obviously you want to train this model on social media data, because social media so if you train a model on newspaper data and then you let it run on social media, it'll just have a disconnect between how people speak in social media, no spelling and no capitalization and like, I don't know, all these hashtags and all that stuff, right? The model wouldn't know what to do with it, right? So if you actually want to understand social media, you have to train it over data that at least includes also some part of social media. At the same time, I do think that the libraries have great data in that it is different from the web data. You have a lot of correct text and a lot of text on many different subjects. And I think this data is probably super valuable to train language understanding modules as well.
Thank you.
Okay, we've got time for one final question. Tiberius? Can we get the microphone over the room?
Oh. A hand somewhere? Oh, that's far
In the
away.
middle?
Somewhere closer. There.
Do it in phases.
Hello, this is Tiberius Ignat from Scientific Knowledge Services. I have a rather long question, but I'll put it very short. First of all, do you curate data sets? Do you put your data in data sets and do you curate them? And what kind of repository technology are you using? And do you know that the repository technology which is used in academics, if you can make a comparison to that? And do you see text and data mining being mature enough to create, as you said, a day and night difference in how we use the scholarly communication, which reach a massive mass and brings a huge problem because of this huge massive mass can't be followed? And you think it can be something like nano articles in the future, which can filter targeted knowledge while preserving principles like citations and principles like peer reviewing. So something about the technology repositories for your data as curation and.
Okay, so so maybe first for the curation part. So I'm not super sure what is curation in the library context. So the one thing that we do in terms of curating the data is that, for example, user reviews, they have to be checked by a human. That the user reviews, because they appear on the web page, right? So somebody has to check that the user review is not, hasn't, some people write terrible things on the internet. So you have to make sure that before it actually appears on the website, a human has approved it. So in a sense, this would, I guess, be curation, that at least the trolls are filtered out, right? Or the very negative people are filtered out, right? For the second part, I'm not super sure how I can answer this. So I do think that the technologies are maturing rapidly. And I think especially these technologies such as document classification, sequence labeling, I think these technologies, especially this year, have become so much better that they are actually, they are becoming very reliable, right? But the question, of course, for you will always be, and for every use case will always be, the machine will not be as good as the human, right? So the question is, can you tolerate a small error? Is that a problem? And there's always a trade-off. So there's something called a precision recall trade-off, where the question is, do you want your machine to make the right decision, or do you want it to make complete decisions? So for instance, is it okay for you if the machine, so is it more important for you that when the machine makes a decision, it's actually correct? And maybe sometimes it doesn't make a decision because it isn't so sure? Or do you want to have want the machine to actually capture a lot of the data, and you can tolerate that some of the decisions are wrong? So this is something that you can influence actually when you design the system. But yeah, I would say it's the time for using this technology for organizing data. Yeah. I'm sorry?
What repository technology are you using?
What
technology you are using for your repository?
As in the code technology or the neural networks or
When you
software? Yeah.
have data sets, what kind of technology do you use for putting those data? Storing them, preserving them, and so on?
Oh, storing the data. Oh, good question. So we. Yeah, so I think we have an internal cluster of machines where we somehow store them. It's just like a normal, like some cluster of hard drives, and so we just dump the data on hard drives, basically.
On that note, for those of us who have to look after our data indefinitely. Anyway, thank you so much, Alan. We're out of time, but would you please thank Alan? That's great.